Hey everybody, I'm trying to get better at posting more often, and so I'm trying to get two things done at once. So I'm going to start filming on my way to work in my car. So a lot of you probably are wondering why black holes are so important and why I'm talking about them all the time. The reason why is because black holes aren't just this area or this region where gravity is so intense nothing escapes, not even light. Black holes store and project quantum information as holograms. They're literally giant holographic projectors. And the one way to think about it is the singularity of a black hole is where all this mass goes into the black hole, and at the center of the black hole, the singularity, it converts back into light. Mass is really just tangled light, and so light converts to mass through interference patterns, through colliding with itself or interfering with itself, and then mass converts back into light. Nothing's ever destroyed, it's just eternally transforming. And so when mass goes into a black hole, it all focuses on the singularity, like a magnifying glass focusing light onto one little point. That singularity is an interference pattern. Think of it like bumps and waves in the ocean. And there's virtual particles of something called Hawking radiation. Stephen Hawking's proved that all throughout space-time, these virtual particles are popping into and out of existence from the uncertainty principle. One virtual particle has negative mass and one virtual particle has positive mass, and they basically pop into existence from the uncertainty principle. It's too long to explain why, but they do. They instantly annihilate each other and they're gone. But he asked, what happens when we see virtual particles or Hawking radiation pop into existence and they're right at the event horizon of a black hole? What happens then is that the particle with negative mass is inside the event horizon and it falls into the singularity. The other particle, or virtual particle of Hawking radiation that has positive mass, is just outside on the event horizon. And the two particles of Hawking radiation, one positive mass, the other one negative mass, they're quantumly entangled. What that means is that when one is found spin up, the other one is found to be spin down instantly. Or one is found to be a 0, the other one is found to be a 1. So they're mirror reflections of each other. So you have this virtual particle of Hawking radiation with negative mass, and it's inside the black hole. The black hole is an interference pattern like waves on an ocean, and that virtual particle is bobbing up and down on that interference pattern. Since it's entangled with another virtual particle that is on the holographic screen, that virtual particle on the holographic screen mirrors the behavior of the virtual particle in the singularity. It's literally like an infinity mirror, where the singularity is like a spherical mirror, and then the event horizon is another spherical mirror, and that information in between them, which is projected on the Hawking radiation, is projected through a quantum mirror or through quantum entanglement back and forth and back and forth. So if you think of it like a mirror, all reflections are mirrored in this quantum state. So all possible picture frames of me and you and of all possible quantum states, they're all together in the singularity in superposition, all mixed together as an interference pattern. And they're all jumbled on top of each other, so you can't tell what one thing is doing and what another thing is doing. But when you spread that information out over a very large surface area of our observable universe, which is the event horizon, then you can say Jason is here relative to Dana in California, etc., etc. And so we are the holographic projection of the internal state of a black hole. And black holes, that's what they are. They're more than just these intense areas of gravity. They store quantum information and they project it back out into the universe. And the angular frequency of the Hawking radiation that is leaving the boundary of the black hole, it's what tells you what's going on in the black hole. So there's an equation called the reduced Planck constant times angular frequency equals mass times the speed of light squared. And if we solve that for angular frequency, we get angular frequency equals mass times the speed of light squared divided by the reduced Planck constant. And what that means is by looking at the Hawking radiation that is leaving the boundary of the black hole, it allows us to understand the mass, the charge, and the spin of what's going on inside the black hole, as though we are watching a movie through a mirror, and that mirror is the event horizon. We can't see in a black hole because nothing can escape a black hole, not even light. But we can see the reflection of what is happening in the black hole by looking at the holographic screen or the event horizon. So it's this sneaky way that the universe allows information through Hawking radiation and a holographic projection to escape from the singularity and be imprinted as a hologram onto the event horizon. So I hope you all enjoyed it. I'll start trying to post a lot more videos, and pretty soon, hopefully, I'll start having some. I'll be writing on a chalkboard and going over the equations with you for those who are interested in it. Okay, have a great day. Bye.